Hey Math Masti fans, welcome to your favorite channel Maths Masti. I am Jatin Joshi and today we are combining two fascinating worlds, chemistry and algebra, to solve one of the trickiest problem for the students, balancing chemical equation. Yes, you heard it right. We will use algebra to make balancing super simple and logical. By the end of this video, you will feel like a balancing wizard. So grab a notebook and let's dive right in. First, what is a chemical equation? It's a way to represent what happens in a chemical reaction. So here it is an example H2 plus O2 and the product is H2O. But wait, this equation isn't balanced, meaning the number of the atoms on the left doesn't match the number on the right. And we know the law of conservation of mass. Matter cannot be created nor destroyed, so we need to balance it. Means here there are two hydrogen atoms and two oxygen atoms. They are combined and react to make a product H2O. But here there are two hydrogen atom and only one oxygen atom. As we know, according to the law of conservation of mass, matter cannot be created or destroyed. So we need to balance this equation. Now let's begin in algebra to solve this. Instead of using or guessing the coefficients, we will assign variables to let's balance this equation step by step. First of all, we assign the variables to each component. First of all, let coefficient coefficient A of hydrogen atom, let B coefficient of oxygen atom, and let's see the coefficient of H2O. What it means? It means A, B, and C. They are the coefficient of A is the coefficient of H2, B is the coefficient of O2, and C is the coefficient of H2O, which is on our right side, our product. So the equation become AH2 plus BO2 combines and react and give us the product CH2O. Write the equation for each element. We will write the equation for each element. Let's for hydrogen. For hydrogen atom, we write the equation means we have two molecules of hydrogen and its coefficient is A. So we write it as 2A. It is on our left side, means on the reactant side. At the product side, we have two hydrogen molecule, so we can write it in 2 and the coefficient is C. We all know the molecules on the reactant side is always equals to the product side. It means left side is equals to right hand side, means hydrogen atoms should be same on both the sides according to the conservation of mass. So we can write is equals to, it means 2A is equals to 2C. For same we will do it for oxygen atom. For oxygen atom, for oxygen we have two oxygen molecules on left hand side and one oxygen molecule on right hand side. So our equation will, their coefficient is B is equals to C, because there is no more atoms than one, so we'll write it only C. According to the law of conservation of mass, reactant sides is equals to product sides molecules. So 2B is equals to C. Let's solve the equation. First we will give the numbers to the equations. Equation number 1 and this is equation number 2. Write down the equation number 1 which is equals to 2A is equals to 2C. We all know that we can cancel it here. 2 cancel out, it means A is equals to C. Let we can choose A or either C. I'll choose A. A is equals to 1. Let's suppose A is equals to 1. It means if A is equals to 1, then C is also 1. For now, we will put the value of C in equation number 2. So what we will get? 2B is equals to 1, means B is equals to 1 by 2. Now we have all the coefficients, means A is equals to 1, B is equals to 1 by 2 and C is equals to 1. But wait, B is equals to 1 by 2. It is in a fraction. So to eliminate the fraction, we will multiply all the coefficient by the denominator, means 2. Means to eliminate the fraction, we will multiply all coefficients by 2. So what we will get? A is equals to 1 multiplied 2 is equals to 2, means we will get A is equals to 2. And on multiplying B is equals to 1 by 2 multiplied by 2, we will get B is equals to 1. And for C is equals to 1, on multiplying 2, we will get C is equals to 2. Now here we have all the coefficients value. So we will write the balanced equation. This is our equation after assigning the variables to the each component. Now we have all the values of the coefficients. So the balanced equation we will get as we have the value of A which is equals to 2, B is equals to 1 and C we have is equals to 1. So on putting the values in the equation, we will get 2 here at the place of A, 1 here at the place of B and 1 at the place of C. On putting the metals or the elements H2 here, O2 here, sorry we have 2 at the C, so we will get here H2O. The complete balanced equation is 2H2 plus O2 is equals to 2H2O. Now here we can see here that there are 4 H2 atoms, means 4 hydrogen molecules at left hand side and 4 hydrogen molecules at right hand side. Let's come on the oxygen. We have 2 oxygen molecules on left hand side and there are 2 oxygen molecules on right hand side. Now our equation is complete, means balanced. Here is the example for balancing the chemical equation. It is unbalanced chemical equation. We will complete it by using the algebraic coefficients. So here we go. Fe plus O2 will get Fe2O3. On putting the algebraic expressions, we'll take here A, B and C. Now it's our reaction. So let's see, for Fe, for iron, we have A on the left hand side and on the right hand side we have 2C. These are equals because of the law of conservation of mass. For oxygen atom we have 2B, which is equals to, there are 3 oxygen molecules on the right hand side and the coefficient is C, which is equals to 3C. We will give it equation number 1 and equation number 2. On solving the equation number 1 and equation number 2, we let C is equals to 1. Let's suppose C is equals to 1. On putting the value in equation number 1, we get A is equals to 2 multiplied by 1, which means A is equals to 2. Now we have C and A. Let's find the value of B. Here from equation number 2, we have 2B is equals to 2C. As we know, we have supposed that C is equals to 1. On the putting the value of C in equation, we will get 2B is equals to 2 multiply 1, which is C, and 2B is equals to 2, and on further solving this, we will get P is equals to 1. Now we have all the variable values, means A is equals to 2, B is equals to 1 and C is equals to 1. We make a mistake. Here is 3C. Here is 3C. So now on 3, you have to put here 3. It's also 3 and it's 3 by 2. So the value of B is equals to 3 by 2. To eliminate the fractional value, the fraction, multiply all the coefficients by 2. Why we multiply by 2? Because the value in the denominator is 2. So we will multiply all the coefficients to the 2. So we will get A is equals to 2 multiply 2, A is equals to 4, and B is equals to 3 by 2 multiply 2, to cancel out, P is equals to 3, and for C is equals to 1 multiply 2, we will get C is equals to 2. Now we have all the coefficients and there is no coefficient in fractional. So on writing the balanced chemical reaction, what we have after assigning the coefficient A, P and here C, AFE plus BO2 and CFE2O3. On putting the values of the coefficient in the equation, we will get 4 here, 3 here and 2 here, means 4Fe plus 3O2 and we will get 2Fe2O3. Now calculate the molecules on the left hand side and the right hand side to verify that our equation is balanced or not. Here are 4 Fe molecules, 4 Fe molecules here, and here there are 2 and 2, 4 molecules of Fe iron is on right hand side. Let's come on the oxygen molecules. There are 6 oxygen molecules on the left hand side and 3 multiplied by 2. Here also 6 oxygen molecules on the right hand side. Now this is the complete balance reaction. Let's move further for the complex chemical reactions. Here is the combustion of methane. The equation is CH4O2 combines and react to give us the product of CO2 plus H2O. On assigning the coefficient, we'll get the equation ACH4 BO2 CCO3 BH2O. We assign all this coefficient to the reactants and the products. So we will get the equation for the carbon. For carbon, we have the equation that C, there is only one carbon atom. So we have A on the left hand side and at the right hand side we have one carbon atom and the coefficient is C, means C. A is equals to C. This is our first equation. For the hydrogen atom, for the hydrogen atom, we have 4 hydrogen atoms and the coefficient is A, means we get 4A, which is equals to, there are 2 hydrogen atoms on the right hand side and at the product side we have the coefficient D, it means we have 2D. On further solving this, we will get 2A is equals to D. This is our second equation. And the last one is for oxygen. We have 2 oxygen molecules on the left hand side, on the reactant side. So we will get 2 and the coefficient is B. So 2B is equals to, on the right hand side, means at the product side, we have 2 oxygen molecules with the coefficient C, means 2C, and the 1 oxygen molecule with the coefficient D plus 2D. Okay, sorry, D, only D. There is no oxygen, 2 oxygen molecules in H2O, so only D. It is our third equation. On solving the equations, first of all, let A is equals to 1. From equation number 1, we get C is equals to 1, because all we know A is equals to C, means if A is equals to 1, then C is also equals to 1. Okay, on putting the value of A is equals to 1 in equation number 2, we get 2a is equals to d. On putting the value of a, we will get 2 multiply 1 is equals to d, which is equals to 2. It means we get d is equals to 2. Okay, there is only one coefficient left. Which one? It is b. From the equation number third, on putting the value of c and d means 2b is equals to 2c, c is equals to 1, multiply 1 plus d is also d is equals to 2. On solving this, b is equals to 2 plus 2 and 2b is equals to 4, and we will get b is equals to 4 by 2 and b is equals to 2. Now we have all the coefficients. A is equals to 1, b is equals to 2, c is equals to 1 and d is equals to 2. A is equals to 1, b is equals to 2, c is equals to 1 and d is equals to 2. We have all the coefficient. Then the assigned coefficient equation means the unbalanced equation was this. And we assign the coefficients A, B, C, D, and on putting the values of these coefficient in the equation, we will get the balanced equation. Means CH4 plus B, which is two oxygen molecules here. We will get either product is C, which is 1, which is equals to CO2 plus D is equals to 2, means 2 water molecules. This is our balanced chemical equation. Now check. Carbon atom 1 carbon here, and on the product side 1 carbon atom. Okay, for hydrogen 4 hydrogen molecules on reactant side and 2 into 2 4 hydrogen molecules on product side. Oxygen atoms 4 oxygen on reactant side and 2 4 on product side. It is our complete balanced reaction. Formation of ammonia, NH2. Here is the unbalanced chemical equation. N2 plus O2 gives us the product NH2. It is unbalanced equation. How can we say this? Because on the left hand side nitrogen molecules are 2, but on the right hand side there is only one nitrogen molecule. So we will assign the coefficients, algebraic coefficients. A N2 plus BH2, the product we get is equals to CnH2. What all we have to done? We have to find all the coefficient to make this unbalanced equation to the balanced chemical reaction. As we know, for nitrogen, the equation is 2A, 2 nitrogen molecules, and A is the coefficient. On the left hand side, on the right hand side, nitrogen molecule is 1 and the coefficient is C. So this is our first equation for hydrogen. For hydrogen, we have 2 hydrogen molecules on left hand side and the coefficient is B. 2B is equals to 2H2C, means coefficient is C and 2 molecules. On further solving this, we will get P is equals to C. Okay, we'll give it equation number 2. If let a is equals to 1, if a is equals to 1, from equation number 1 we get 2a is equals to c is equals to 2 multiply 1, and c is equals to 2. If c is equals to 2, then from equation number 2 b is equals to c is equals to 2, which means b is equals to 2. All we have find all the coefficients, means a is equals to 1, b is equals to 2, and c is equals to 2. On putting the values of the coefficients in the equation, in the reaction, we will get n2 plus b. At the place of b we will put 2h2. On the place of c we will put 2NH2. Here we can see that there are 2 nitrogen molecules on the left hand side and 2 nitrogen molecules on the right hand side, and here 4 hydrogen molecules on the left hand side and the 4 hydrogen molecules on the right hand side. It means this reaction is now balanced. Now let's come to our last example, but it is a little complex. So let's start the algebraic coefficient to all a, b, c and d. This is unbalanced because here are 2 carbon atoms, but at the product side it is only 1. Oxygens are 3, 2 and 3, here 3. H is equals to 5, but here is only 2. So now write the equations first for carbon. For the carbon, we have 2 carbon molecules on the left hand side and the coefficient is A. So 2A, which is equals to the product side. It should be equals to the product side. So here is 1 carbon atom and the coefficient is C. And it is equals to C. We will give it equation number 1. We have to put in it equals because we all know the law of conservation of mass. Mass neither can be created nor be destroyed. It means the molecules in the reactant side is always equals to the molecules present in the product side. It is for carbon. Now for hydrogen. For hydrogen, there are 5 and 6 molecules in reactant side and the coefficient is A. So we write it 6A, and on the product side we have 2 hydrogen molecules and coefficient is D. So 2T. On further solving this, we will get D is equals to 3A. We will give it equation number 2. For now, oxygen molecules. For oxygen, there are 1 oxygen molecules with coefficient A, means A, plus 2 oxygen molecules with coefficient B, 2B, and which is equals to 2 oxygen molecules with coefficient C and 1 oxygen molecules with coefficient D. This is the third equation. Now let A is equals to 1. If A is equals to 1, from equation number 1, we get what we get? C is equals to 2A. On putting the value of A in this, we'll get C is equals to 2. From equation number 3, from equation number 2. From equation number 2, we get what we get? We get D is equals to 3A. On putting the value of A in this, we will get D is equals to 3. Now come to question number 3. On putting all the values in equation number 3, putting all the values in equation number 3, we get A plus 2B is equals to 3C plus B. Only we don't have the value of B. So we will put the remaining values. A, which is equals to 1, plus 2B is equals to 2C, C is equals to 2, and D is equals to 3. On solving this, 2B is equals to 4 plus 3, and here 1. On transferring this 1 to the right hand side, the sign will change. It means it is in a positive. After the transfer, it will comes in negative. It means 2B is equals to 7 minus 1. 2B is equals to 6 and B is equals to 3. Here we done. We have all the coefficients. A is equals to 1. A is equals to 1. B is equals to 3. C is equals to 2. And D is equals to 3. Now on putting the values of these coefficient in the equation, we will get C2H5OH plus at the B is equals to 3 means 3O2. The product side C, which is equals to 2, means 2CO2, and now for D is equals to 3, we'll get 3H2O. This is now our balanced chemical equation. For now, we all have done for the examples. Amazing. This one looked tricky, but with the algebra, it's just maths. Here a challenge for you. Try balancing the equation using algebra. The equation is now KClO3 and the product side KCl plus O2. Assign variables. Write equation for K, Cl and O and solve. Drop your answer in the comment box below and I will feature the correct solution in the next video. And there you have it. With algebra, balancing chemical equation become logical, easy and even fun. If you found this video helpful, hit the like button, share it with your friends and subscribe to Maths Masti for more amazing lessons. Let me know in the comment which equation you want me to balance next. Until then, this is Jatin Joshi signing off. Keep learning, keep solving and stay curious. See you next time.